Question number 71. Which among the following is a non-polar molecule? So student, let's see which is a non-polar molecule, starting with BF3. In BF3, it is very clear that all the bond dipoles cancel out each other. As a result, dipole moment is 0 and the species or the molecule is non-polar. Moving to next, we have ClF3. All the bond dipoles will not cancel out each other. As a result, dipole moment is not equals to 0, or we can say that the molecule is polar. Moving to next, here also the molecule will be polar because the bond dipoles will not cancel out each other. As a result, dipole moment is not equals to 0, or we can say that the molecule is polar. Moving to last, CHCl3. The bond dipoles again will not cancel out each other. As a result, we can say that the dipole moment is not equals to 0 and the molecule will be polar. So among the given molecules, the only non-polar molecule is BF3. That means the correct answer is option number 1. Moving to next question, which is question number 72. Let's read it. In which of the following pairs of molecules or ions the central atom is sp3 hybridized? Starting with option number 1, SO3. Students, in SO3, sulfur has 3 bond pairs. As a result, this is sp2 hybridized. Moving to next, in SO3 2 minus, sulfur has 1 lone pair and 3 bond pairs. As a result, this is sp3 hybridized. Moving to next, student, in SO4 2 minus, sulfur is sp3 hybridized. Moving to next, PO4 3 minus. In this case, phosphorus is also sp3 hybridized. Moving to further option, SF4 and CH4. SF4, in SF4, sulfur is sp3 dehybridized because has 1 lone pair and 4 bond pair. In case of CH4, carbon is sp3 hybridized. Moving to the last option, in PCl3, phosphorus has 1 lone pair and 3 bond pairs. As a result, this is sp3 hybridized. And in ClF3, chlorine is sp3 dehybridized. So the only pair in which the central atom of both the ions are sp3 hybridized is option number 2. That means the correct answer is option number 2. Moving to next question, which is question number 73. Let's read the question. The species which is our linear in shape is R. So student, let's start. BeCl2. In BeCl2, boron has 2 bond pairs. As a result, this is linear in shape. Moving to next, CS2. Student, CS2 is also linear in shape. Moving to NO3 minus. Student, this is trigonal planar in shape. This is trigonal planar in shape. That means option number 1 and 2 both are linear in shape. So the correct answer is option number 4. Moving to next question, which is question number 74. Let's read it. Which of the following has p-pi d-pi bonding? Student, p-pi d-pi bonding, we have to identify that in which case it is present. So only compound in which the central atom can contribute d orbital is H3PO3. So in case of H3PO3, there exists p-pi d-pi bonding, and in rest of the cases there exists only p-pi p-pi bonding. So let's discuss the structure of H3PO3. Here, let's start with the electronic configuration of phosphorus. This is 1s2, 2s2, 2p6, 3s2 and 3p3. So S subshell has 2 electrons and P subshell has 3 electrons. Here, phosphorus forms 5 bonds, out of which one is a pi bond. So, we have to write the electronic configuration in the excited state also. So, one electron from the 3s subshell will shift to the 3d subshell. So, 3s will acquire 1 electron, 3p will acquire 3 electrons, and 1 electron is now present in 3d subshell. So students, H3PO3 forms 4 sigma bonds and 1 pi bond. OH, OH and H. Student, this pi bond is formed between the p orbital of oxygen and the d orbital of phosphorus, which results into p pi d pi bonding. That means the correct answer is option number 2. Moving to next question, which is question number 75. Let's read it. In SO2, the number of bond pairs and lone pairs present respectively are. Student, for this question, let's draw the structure of SO2. Sulfur has 1 lone pair and 2 bond pairs. And oxygen, each oxygen atom has 2 lone pairs. So the number of bond pairs is equals to 4 and the number of lone pairs is equals to 5. That means the correct answer is option number 4. Moving to next question.